Well, hi folks, and welcome to episode 166 of Retro Power Uncut. And as usual, you're starting with Nat in the fabrication shop. And we started the week, you may recall last week we had a power disaster. Lost one phase of our three-phase supply, which was a bit of a problem. Lots of digging occurred, lots of people bumbling around in very wet holes in the ground trying to find faults. I'm not sure whether they found the fault or not. There's a lot of cables down there. I had a little look down there earlier. There's a temporary supply still run in, but I think we're actually back on the proper supply now, and the temporary supply is just made off into a temporary isolator. So I think they've got to come back when the hole isn't, when they can pump the hole out and finish off sorting the cables out in there. But yeah, we have power anyway. That's the main thing. So on Monday this week, we started the week with a reblast of the Project Churchill two-door Mark II Jaguar Coupe body shell. Rich started the week going back over the work he'd already done at the disaster point on Thursday. So got that blasted, went over everything, checked everything was okay, and then we got into zinc metal spraying. So got set up and got all the underbody, under the inner wings, round the body, round the apertures on the body, anywhere where it's easy for the surfaces to be damaged, and where a bit of sacrificial anode protection to the steelwork would make a lot of sense. On that subject, I'm going to quickly go off on, all the viewers will no doubt laugh at that point. I'm going to go off on a bit of a diversion about the zinc metal spraying. I've talked about it at length in the past on various videos. However, I noticed there were a lot of questions, certainly last week, about the process. So I'll do a little diversion and a little explanation of how it works. And here, as if by magic, I have our little home put together setup, which is based on a MKII 11E metal spraying gun. This setup runs from three services: compressed air, propane in there from our propane bottles, and oxygen in there from the oxygen bottle. We set the pressures on the regulators, set the flow rates on the flow meters, set the compressed air pressure on there, and then all three of those are fed down these three lines: air line, oxygen line, propane line, all to this gun. And if there was, I think I'd noticed in the past a couple of people saying about me wearing my nerve gas mask doing the job. You don't want to breathe in zinc fume, it's very bad for you. And an air-fed helmet would be very nice, but when you're already trailing those three services around, plus the actual zinc wire that's being fed to the gun, another airline would be pretty cumbersome. So I'd rather run a filtered respirator and do it that way, so I'm not hauling another service around with me, because it's pretty cumbersome just hauling these around. This gun is not particularly light. The way the gun works, compressed air is fed in and operates a turbine in here, and that's the adjuster for the so like a little roller epicyclic unit in there that actually is driven by a turbine, and then that drives a set of drive rollers inside here that pull. This is the zinc wire. It's 1/8 of an inch diameter pure zinc wire, which comes on a coil, and I have a little unwinding reel that I have behind me when I'm doing it that lets me pull more zinc wire in. That's fed into the back of the gun through this gripper arrangement, this snubber arrangement that stops it pulling back out of the gun, and then it's driven a bit like a MIG welder. There's a pair of rollers in here driven by this air turbine that pull that through and push it out of the nozzle. I'm not going to undo the nozzle. There we go. This is the air cap on the nozzle. The compressed air is also then fed out of the nozzle. It's not unlike a paint spray gun. The zinc wire is fed through the middle of the nozzle there, as you can see that coming in and out like that. And then the propane and oxygen is fed, mixed, and by this valve here, and then fed out of those jets around that piece of zinc wire there. And then the compressed air is fed out around here, which prevents the heat from that then damaging the rest of the gun, and also then projects. The zinc is melted by this flame, and then the air projects that zinc out in a spray out of the front of the gun, and that spray is constrained by this air cap which goes on there. So that's briefly how that works. This gas valve here has a position where it allows you to light the gun and then full spray position. So there, flick it to there, ignite the gun, flick it to there, it goes into full compressed air and gas flow at full, and it's very similar to a cutting torch flame, only quite a lot higher output than a cutting torch flame. It's a pretty high heat output. It uses a lot of propane and oxygen. And then the final thing here is there's a valve on the side which you can operate like that, and that toggles on and off the feed to the turbine itself to toggle on and off the zinc wire feed through the gun. So when you see me doing my spraying, I'm toggling that on and off. Each time I need to pull some more zinc wire to slack into the zinc wire, I'll stop the feed, pull some zinc wire slack up so I can get at what I'm doing again, and I'll toggle that back on, carry on spraying, toggle it off, do my moves around, toggle it back on again. So that's what I'm doing when I'm fiddling around with the gun there, is I'm putting that wire feed on and off. And that's basically how it works. So for those who are interested, that is a MKII 11E metal spray gun. That was new in 1989, but I bought it as a new old stock unit. It had never been used. They're pretty expensive new. I think the current model from MKII, they make a gun that outwardly is very similar to this, and I believe it's called a 16E metal spray gun. They used to do a high speed and low speed gun. This is a high speed gun designed for spraying aluminium and zinc wires, anti-corrosive wires, where you're spraying a high volume of metal. The low speed guns are for spraying things like molybdenum wire and nickel wire, for doing shaft build up and hard facing of things and that sort of work, because the gun can be used for a few jobs. It's not just anti-corrosion, but for us it's an anti-corrosion thing. It's something that's used a lot in the oil industry, marine wind turbines, that sort of thing. A lot of it's done with an arc spray gun now, where it's electrically, the zinc is vaporized or liquefied electrically and then sprayed out using electric arc between two zinc wires. The flame spray has its benefits. A, it's a lot cheaper to get kitted up compared to arc spray, and actually the spray finish is a lot finer, which is handy when we've got to paint over it with a reasonably refined coating on the underside of the vehicle that we're spraying. All our suspension components, not unlike the ones next to me here, they are actually arc sprayed by a contractor that we use for all our powder coating, a company called MKII in Coventry. All of our suspension components, all of the bigger, heavier duty suspension components are shot blasted, zinc arc sprayed, and then powder coated at MKII in Coventry. But the flame spraying for the car underbodies we do in-house, just so that we don't have to move the bodies off our site, and that then the coating is sort of, we can offer a warranty because it's based on our service. It's all done in-house. We're in control of that process, so that's why we do that work, and that's why it's split. But yeah, that's a reasonably brief background to what that kit is, because as I say, I'd seen a few questions on that. Moving on from that, then I'm going to briefly stop at this, and then we'll go and look at the car. So once the zinc metal spraying was done, the next stage was preparing for epoxy primer. That's in there, but in parallel to that, there's a few other jobs going on. One of those was that I needed to finish the front anti-roll bar setup on this car. We never actually completed, while the car was rolling, the anti-roll bar setup. We'd ascertained where we were going to put the bar, but we hadn't actually designed and made the brackets. So I've just done this, drawn up and fabricated this bracket that goes across here, that acts as the wishbone tie brace for the front wishbone mounts. It's going to have a bolt into here, into these front arms here, and then that will take Mark II Escort anti-roll bar clamps, which enable us to use quite a wide variety of anti-roll bar diameters, because there's a readily available range of different diameter bushes to suit those clamps. And then we will make the bar. We'll make the bar in cold drawn tube with fish-mouthed and welded flanges on the end. And then we'll create the blades, because they've got to navigate quite a tortuous route through to the point where they mount to the wishbone. So we're going to make then plate blades that go through there to the ends of the actual bar. So that's underway now. The basics are there. I've just got to get these nuts welded in on there. We'll go and have a quick look at the car then. So the zinc metal spray is all complete, and the surface work is now underway, which is going to be a long slog. There's an awful lot of work to do, but it has started. So the car, following the zinc metal spray, was sanded There was some phosphoric metal prep used on the roof just to take care of. There were a few, Gaz was concerned about some areas of little not pinholes, but pin indentations of rust in the roof, which we can't really remove by sanding, can't really remove any other way. If we blast it, we run the risk of distorting things, so a bit of phosphoric treatment just put on just to take care of those. That's a bit of a balance between doing that and then not getting it on too much of the zinc, because that reacts with the zinc, so there's a bit of a juggling act there, but that's sorted on the roof. It's got that dealt with. Then that was dried off, the whole car warmed up in the booth, and then the epoxy primer applied, which is the grey finish that you can see inside the boot there and inside the car. That was also applied over the whole outside, and then 2 coats of polyester at the minute. So far, two sessions of 5 coats, doing 2 sessions. So we've then applied 5 coats of polyester spray surfacer to this. We use a product that a lot of people would be familiar with would probably be U-Pol Reface. We don't actually use U-Pol Reface, we use another product that most people won't have heard of, so there's not much point me talking about it, but we use with a product we're really happy with. We get no sinkage with it. It's an extremely good product. It sands quite nicely, but it is quite hard, doesn't cause sinkage. We're very happy with it. So that's had 5 coats of that applied, and then the initial blocking to be done on that, which will then expose all of the surface areas to attend to. There'll be some more little bits of hammer and dolly work needed undoubtedly as we go through. We've already sort of found one and we'll find some more. But then also localised filler required to level up various areas, sections that Gaz was working on there, that Mark was working on, where we've got a low spot on the back of the roof. There's various bits on the quarter panels that are going to need quite extensive work. So we're under no illusions that this is going to be a quick job, but at least it is now in the body prep area, and we're making the first steps on that lengthy journey. So yeah, much more to come here. Moving on from that, we'll go this way. I'm going to make Jamie run around in circles. I'm going to pick up my coffee as well, actually. We're going to go over to the Interceptor, Project Rooster, as it is now known. I've not actually clarified why it's called Project Rooster. I'll have to find out for the next video, or Cal will explain. Yeah, some progress has been made on this. Stu's got the rear axle assembly out, and yesterday Stu and Tom removed the engine and transmission assembly. The engine is it is Chrysler, isn't it? It's a Chrysler Hemi, or equivalent now, it is a Chrysler, isn't it, Stu? The engine is Chrysler, isn't it? Yeah, it's a Chrysler Hemi, new crate Chrysler Hemi engine, and ZF 8 HP auto transmission. They've been removed from the car for the moment, mainly for access, and also there's various jobs we need to do which needed them out. But also we didn't want all the weight in the front of the car when we were removing the rear axle, because the most significant first phase of work is a round of revisions that need to be done on the rear axle assembly. This is a Heights, I can't remember their exact term, but Heights, H-E-I-D-T-S, a US company, made this assembly, which is actually quite a decent assembly. Some modifications have been done to it which we were not entirely happy with, and so we're revising those, and while we're revising those we're also going to add some compliance into various areas. The upper control arms on this are rose jointed both ends. We're not happy with that, that'll transmit too much noise. The lower control arms use what I would deem insufficiently large bushings for the level of compliance that we're going to need on what's going to be a GT car. So we're going to revise those, revise the upper arms so that they can have a more compliant bushing in, revise this bushing because this bushing is insufficiently large, again, for the amount of compliance required in the car, so we're going to change that, and then we're going to do some refabrication of the mountings, the forward mounting for the diff and the suspension carriage, because they've been revised already from the original design, and we're revising them again and putting them back quite close to the original design. Not the same, but quite close to the original design, in that the original design was actually fairly good. And we're reasonably happy with that. And we're also revising the brake setup. Strangely, for somebody that always moves brakes outboard, I'm actually moving them back inboard on this, because this rear end was not designed as an outboard brake rear end, and the brake torque I don't think that those lower control arms are really strong enough to resist the brake torque on a car of this weight. I don't know that. I haven't done the calculations, and I'm not about to do the calculations. I'm working on the basis that Heights originally designed this with the inboard brake setup, so those arms and those uprights were never designed to resist that brake torque. And that's a concern to me, so I'm putting it back to how Heights did it on the basis that they designed it that way, and I'd rather keep that original design. So that's being modified. Once those modifications are done, the main one obviously being the big bushes that actually hang the whole lot in the car, I need to do those before we can mount that back in the car. Once that's mounted back in the car, then we can proceed with a load of other modifications and operations around the rear end. So things are moving ahead on that. And in parallel with that, Stu is working on the HVAC unit. We're doing a complete, well, there was no provision for an HVAC unit in the car. There was, but it wasn't a very good one, and it wasn't really, it hadn't been fully thought through. So we're using a unit that we've used on various cars recently, which we're pretty happy with, which is a Vintage Air Magnum, and this will be a generation, I can't remember now, is this a generation 4 or generation 5? It's the latest generation Magnum combined AC and heat unit. It's the sort of the highest model that Vintage Air make, and it's actually a really good unit. But it is very large. We've mentioned the size of them before. They don't fit very readily in the body shell. But there's not really any way of making it a lot more compact and still have it do all the operations it needs to do. So we've had a little look at where we can actually mount the unit in the car, and we've actually found a chunk of spare space where we can mount it, which is above the near side footwell in the bulkhead. So Stu's carrying out some modifications to the bulkhead, closing off some original apertures, opening up some new apertures, adding some reinforcement to re-strengthen the bulkhead where we put the cutouts through it. And then he's going to be mounting up that HVAC unit as soon as that lands. We're mocking up with a previous generation unit, and it's extremely similar, but it's not quite the same. But we'll do the initial mock-up with that, and then the final holes and cutouts and mountings will be done with the actual correct unit here once that arrives. I believe that's been ordered, so that should be on its way. So yeah, the beginnings of progress on the Interceptor. Looking forward to that continuing. As I say, we mentioned last week, Stu had been working on the door apertures. We're actually waiting for the door opening window glass to arrive, because we need that to do the final adjustment of the fits of the doors into the body shell, and to do a bit of revision on the roof gutters, a bit of alignment on the roof gutters to get them fitting better. But that's all progressing forwards and quite pleasing, really. On Redux, Scott and Sam have been working on that. Scott's got the rear outer inner arch extension fitted on the off side of the car, on this side of the car now. That had been left off for a while some other work was done. That's now mounted onto the car. Now that's on the car and fitted and confirmed to fit the quarter panel. We're going to do the same as we did the other side and make a form tool to hold the profile of the arch lip on that, so that we can use that to final fit and finally hammer form the arch lips on the cars going forward, so that we have a bit less manual adjustment and a bit less time consuming work in terms of making that arch lip exactly correct. Previously Scott's had to make them to fit the carbon panel, and it's quite a lengthy process, so we're doing a bit of tooling there to aid that. And then both guys have been working on getting the front bumper fit right. We mentioned last week about revising the front bumper mountings. There's some further revisions taking place on the front bumper mountings, just again really to streamline the operation of building up the front end and just make the bumper doesn't really adjust in the dimension, or didn't really adjust in the ways that you need to make it adjust. So the mountings have been revised so that we can adjust it where we need to adjust it and get everything to line up correctly relatively easily without too much time being consumed. So that's a brief synopsis of where we're at on Redux. As I say, I'm not going to go into great detail on that, because as I say, that's really a Redux project to enlighten everybody on, rather than a retro power project to enlighten people on. We'll skip past the E-Type because the progress on that is not metalwork, metal progress in here at the moment, but Cal will reveal more on that, I'm sure, later, because there's progress going on in the background on that. And then we come over to the Allegros, where Bobby is getting to the point where car number 2 is pretty close to the point that car number 1's at. First off, working the back end, he started fabricating the boot hinges last week. He's finished fabricating the boot hinges and made a very nice job of those. Finished fabricating those and fabricated the gas strut mountings, which will be the openers for the boot lid on the hinges. He's also, I believe, sorted out the boot lid catch, the latch plate and latch arrangement for that. He's finished fabricating the seatbelt mountings. I think he was just nearly done on those last week, but he's got those completely finished now. And then he's moved on to the front end, and there's quite a lot of detail fabrication that's not immediately obvious. First off is the bonnet hinges. So he's working on getting the bonnet hinge mountings added into the engine bay, and they also act as a reinforcer, additional reinforcer to stiffen up the front turrets. And then he's also working on the bonnet striker catch here, which is a significantly modified arrangement. I think we mentioned it before on the previous car, but there's a latch box built underneath here which stiffens the front panel up, stop that flexing, because it was very flexible originally. And then this structure that lives between the two coolers, between the radiator and the AC condenser, this structure then also carries the latch box that the bonnet latches down to, so that the safety catch, which could end up taking quite a load if your bonnet catch fails or you forget to latch your bonnet. Obviously, it's quite a lot of uplift acting on the bonnet, so the panel needs to be reasonably strong. All of that ties into this mounting that also carries the coolers and separates the coolers, and ties into the front panel here. So Bobby's on with the sort of detailed fabrication work on that area at the moment as well. Once those bits are done, I think then it's really on to dashboard area, getting the dashboard up to the same stage this car's at, and then they're pretty much level pegging in terms of where the cars are at. So then we'll be doing a job list revision. Cal and I and Bobby will go through a plan of action on the cars going forward for all the dry build work that then needs doing for provisioning, the usual, we talk about it very regularly, but all the usual provisioning for wiring installation, because these cars, while running an awful lot of Honda components, won't be using the Honda wiring looms. They'll be running our normal sort of combination of a PDU to control all the power in the car and an ECU to run the engine and provide the instrumentation feeds and stuff. So we'll need to plan the wiring loom routing, plan the wiring loom mountings, get all that provisioned in the car, and then the fluid lines, so the fuel lines forward and back, from tank to pressure regulator to engine, and then coolant lines in the front, although the coolant lines are going to be largely Honda actually, they're fairly straightforward, but then also brake lines, everything else that's got to be planned. Again, I think the routings are going to be very similar to Honda, but obviously the car being now slightly shorter than the Honda, everything's got to be shortened, so it's not like we can just use Honda lines, and in any case we wouldn't be able to buy the lines new from Honda as one piece anyway, so we'll be making the lines, but we've just got to put the provisions in to mount them. So that's the next phase in terms of work on these two cars. But yeah, Bobby's getting pretty close now to the final phases of the sort of key structural significant metalwork. In the background, sort of around the corner, Rich has probably been bustling in and out of camera, possibly, I'm not quite sure, but he's busy doing something that I mentioned last week. And it's not, you know, I want to do a grand reveal when we get to the stage of having our new bit of equipment up and running. But in the background, Rich is getting some of the groundwork, if you like, put in place for getting our new machine installed. And one of those things is putting the sort of the power in place for it. So he's putting getting electrical components bolted to the wall, ready to be wired in, and that side of things. So we've got distribution board to go in, isolators to go in, all sorts of electrical things to be bolted to the wall and got in place, ready to be wired up. And also our dust extraction we mentioned before, getting the duct work put in for that, and various other things. So watch this space. I'd love to mention what I'm actually referring to now, but I think what we'll do is hold fire until it's actually in its final resting place before we talk too much about it. But yeah, it's going to be another step up the retro power capabilities ladder once we have that in place. And I think that pretty much ties up where we're at now. So at that point, I'm going to hand over to Cal and let him give you the tour of design and assembly.
Oh. Well, thank you very much, Nat. I'm just going to grab myself a Roundstone coffee, which is emblazoned across my chest. Christmas is coming up ridiculously fast. I've got all the planning to do for our Christmas party, which is generally held at my house and is again this year. Although the team is growing to such a vast size that I'm not sure how much longer it can be at my house. Yeah, so it will soon be upon us. So get in the shop, and if you want some retro power stuff in time for Christmas, get on there quick, because you know what the Royal Mail's like around Christmas time. Right, let's go see what's been going on. So, we shall sidle past this awesome Hemi engine that's come out of the Interceptor next door. I'm sure Nat will have talked about that. And pause for a moment next to the Escort. So a few prongs of progress going on. Upstairs, Alex is still beavering away with wiring. He's basically doing the engine harness design, while Steve is carrying on with the build of the second wiring harness, or the second main wiring harness, should I say. And I think actually Alex is on with the rear leg, so it's kind of a modular harness. One section sits behind the dash, does ECU, PDM, all the instrumentation, everything that's behind the dash, and then it's got bulkhead connectors for the front left and right legs of the loom, a bulkhead connector for the engine loom, and then a connector inside for the rear leg of the loom. So I think actually Alex is on the design of the rear leg and starting to do the layout for that. So hopefully in the fairly near future we'll have the main sort of central harness finished for this one, and the rear harness leg finished for project one. In the meantime, guys have been cracking on with the rest of the HVAC installation. So they're both running Vintage Air Generation 4 heating, ventilation, aircon units. One of the few things we had left to do was the refrigerant and coolant lines inside the car, from the bulkhead connectors to the unit itself. And actually last week Jim was on with, or it might have been earlier this week, just making a custom angled elbow for the bulkhead connectors we've got for the coolant pipes where they pass through into the engine bay. We just wanted something that wasn't quite a standard angle on there, so we've just made our own formed aluminium elbows, which was kind of the last piece of the puzzle. They've gone away to be anodised, and then when they're back we can literally get that all in for the final time. That more or less then buttons up the plumbing, and they finished off this week the remainder of the clutch and brake plumbing. Obviously no clutch plumbing on this one because it's not got an engine and box in yet, which quite excitingly means they were able to bleed the brakes on both cars actually. So both cars technically now have functioning brakes with fluid in. That one's also had the clutch bled. I think Luke is, who I think is lying in the footwell of that car at the minute, is on with some of the final trim panels. So there's going to be a panel in the boot, an upholstered panel on the back of the fuel tank there. So he was just patterning up and drawing up some drawings for both of those, and that finalises all the drawings for the remaining trim panels. So we've got the parcel shell panel, bulkhead panel, rear floor panel, and the fuel tank panel, and I'm just waiting for a delivery of aluminium sheet so I can get all those panels made, and then they'll be going away to be upholstered. And in the meantime, we've been doing a few last bits audio installation. That was something else. So Anthony's been fitting the rear speakers. We're running, I'm not sure if I've gone into this in detail before or not on these, but we're running Audison, or largely Audison audio system. So we've got a fairly compact Audison amplifier in the back there, which is connected to an Audison Beacon unit, which is their Bluetooth receiver. What I quite like about that unit is that it's optical, and you've got an optical input on their amplifier as well that we've used. So it never goes analog until the speaker output. It's a digital signal from the Bluetooth receiver all the way into the amplifier, so there's no, or much less of an opportunity for interference to get in there. And then what we're doing on this, because of the space constraints of the system, rather than running kind of a traditional system where you might have sort of mids and tweeters up front and mids and tweeters in the back, we're basically just running right and left with tweeters in the dash, some little 4-inch mid-range drivers in the doors, and then some large, I can't remember if they're 6 or 7 inch, there might be 7-inch, or maybe even 8-inch actually, bass drivers in the rear, and we incorporated provision for all of those in the Metalwork. and they're all on individual channels of the amplifier, so it's a 6-channel amp. So effectively your kind of level control, rather than being front rear fade, will actually be individual control of the different frequency ranges. And then we've got the DRC AC, which is the volume control knob. You can also click it to go through different frequency levels and the different like right, left balance, etc. And that is what's going on the back of the center console in these, if you've noted the sort of round aperture on the back there. And speaking of the center console, Sam has just been buttoning up the second of the two. We'd already folded up the steel kind of skeleton for it on Project One. We've folded up the one for this car now and then done all the final welds on those. So those are now ready to be leathered, and then the final, I mentioned last week actually, that the final billet piece to go on those, which is the large tray that you can put your phone in, it's got a USB socket in it, etc. They're being machined this weekend, so hopefully everything will come into place nicely. I'll get those trays back, we'll be able to get everything away for anodising, the consoles will be leathered, and then everything can start going together. So it's one of those things where we're kind of getting all the ducks in a row massively, and so there's sort of everything happening in the background, and suddenly it'll all come together. We've got the carpet through for Project One now as well, so I've gone for like a box weave or square weave carpet in a sort of dark anthracite grey, but light enough that the black anodised pedal pads will be a contrast against it. So again, I'm really looking forward to seeing all that come together. And I think we'll have the cam covers for Project One at least next week as well. So all looking pretty good on that lot. A couple of other things, I might as well walk around here I suppose. So I might as well dwell on this for a second. So this is the engine block for Project Churchill. So we've seen some footage of the engine being completely stripped down. We've been going through, or Mark has largely been going through, doing a lot of bead blasting work of alloy castings for these, and also all of the fasteners. I think they're either just about to go for zinc nickel plating, or they might just have come back from zinc nickel plating. But what we're doing at the minute is something we don't usually do, which we're going to actually bead blast the block, because Adam and Nat are completely confident on this block design that all the oil galleries are straight barrel shots and you can get all the bungs out of them. We can be absolutely sure we can clean anything back out of any hidden areas and galleries on it. So whereas previously when we've had concerns about getting blasting media into oil galleries, we've tried dry ice blasting, but in all honesty, it just doesn't work very well. I mean, it cleans up stuff that's easy to clean. Probably the best way to explain it is that if you could clean it off with a hot pressure washer, that's about what dry ice blasting achieves. But you tend to find on some of the areas that have got a little bit heavier alloy corrosion, it just doesn't really fetch it off, and you still have a slight tarnishing of the alloy. So on this, because we're completely confident we can get anything out of it if it got in there anyway, we're actually going to bolt all of the kind of external pieces together. We've made some blanking plates for areas where we can't bolt parts on, and then we're actually going to bead blast this in our blasting room to get that alloy finish back to a really nice finish. Then all the blanking plates we've made will be removed again. We'll give it a really, really thorough wash out, clean out all the galleries, and then we'll have an absolutely immaculate looking block. So yeah, it'd be good to see that taking shape. So that's that. Staying on the straight six Jaguar theme, just briefly touching on this, we've done the alternator mount. It needs to go away now to be coated, but essentially the alternator mount is now made. We knew that area was going to be tight. When we were working out the belt run previously, we had all this lot as a CAD model, and we had the chassis and now the alternator loaded in as a CAD model when we were designing the lower mount, and we knew it was going to be pretty tight because of this water pipe that runs here to here. But it does all work out really well. We're happy we've got enough clearance on the chassis, but we've got the alternator just far enough over that with just modifying this pipe very slightly in length here, we can get that on and it won't be chafing on anything. So that's going to work out well. Good use of that space, which then leaves us loads of room for the air conditioning compressor down here. And speaking of loads of room, or in this case not loads of room for air conditioning, we have finally started on our design work for our air conditioning system on this. Now, we've seen there are a couple of companies out there who have done a kind of variation, a modified version of the standard heater box, which is a metal fabricated box here. It's got a fan that intakes its air from a duct on the underside of the bonnet, Then it blows through a heater matrix in this box and straight into the bulkhead here, and then that distributes the air inside the bulkhead to the various vents. We've seen some people that basically put a combined heater matrix and AC evaporator in a slightly enlarged version of the standard box. But having used quite a lot of different aircon heat systems over the years, I've never been overly happy with the ones that blow through both the heat and the cold. And the only way of, essentially when you turn it to full cold, it just shuts off the hot water flow, which gradually does cool down, and you get cold air eventually. And vice versa, if you change it from cold to hot, it takes quite a long time. So I much prefer the systems more like OEM systems, where there's actually two separate air passages, one through the evaporator, one through the heater, and a flapper that actually changes which of those the air is flowing through, or does a mix of the two. So that's what we're trying to do on this, but I'm trying to keep it quite respectful of the original design. So our intention is to use almost exactly an original heater box, still with the heater matrix in it in the original place, but just in front of the heater matrix we're going to make a duct on there, which will be a 3D printed duct, which then ducts air out of the system down to an additional box we're going to put in the area where the battery would have been, which we've relocated to the other side, through an evaporator unit down there, and then feed back up to the original heater box, but the other side of the heater matrix, just before it goes in here. And where there was originally a shut-off flap in front of the heater matrix to shut off the air flow through the system completely, we're going to repurpose that with a servo motor on it, so we can actually start using that to control how much air goes through the heater and how much air goes through the aircon evaporator. And then that will then be part of a system which we'd planned previously, where we'll have electronic servo valves on all of the vent feeds as well, which will then mean we can use our PDM on this to completely control the airflow electronically. So we can control how much is demist, how much is feet, how much is face, the split of air between hot and cold on here, and that will all be controlled via the PDM, and the information about how it's what you've got selected, if you like, will be displayed on the Motec screen that's going to be in the middle of the dash. So that's something I really like about this car, is that it's very classic looking and very original looking, but then there's just a few little clever touches under the skin, and I'm loving the sort of Motec dash that we're going to have in this, which will kind of take a very classic looking interior, and it'll even have the Smith's gauges represented on it in normal modes. But then you'll be able to enter these additional screens on there where you can change your climate control settings, etc. So it's it's a nice sort of more subtle take on a resto mod than some of our more wildly modified projects. The XJC, I've just had the radiator back. So I think I said before, we built that quite a few years ago. It got a bit of a leak on the radiator core. Sent that back to Concept Racing, who made it, and they identified that the leak was actually on the core itself. So fair play to them, they sent the radiator to the core manufacturer, who did actually attempt to repair the core, but they couldn't, so it ended up having a new core. Concept have then built me a complete new radiator in the pattern of the original, which arrived, I think, first thing today or last thing yesterday. James has got that in. We've just been getting the coolant level filled up in it and getting everything reconnected up. Run it up to temperature, all looks good, temperatures look good, it's bled nicely, the fan kicks in and out, so happy with that. I've just been wiring up and testing the new audio nav unit we've got going in it as well, which was working well. So all I'm really waiting for on that now is the little bezel plate that goes around that radio and the heater controls. That's away being anodised. As soon as that's back, I'm going to etch in, or have laser etched in, the information around the heater control switches. And then as soon as that's done, that can go in, and that is done and can go back to its owner. So hopefully in time for Christmas. I'm just trying to think what else has been going on up in the design studio. So George has been on with a couple of different things. He's been doing the tail end of some of the Etype, the other Etype interior design stuff, which Luke's now taking over. So we've got to the stage we know roughly the layout we want of everything, and now we're moving on to the next stage, which is how we're going to make those components, and starting to elaborate on the design of the components, so they don't just represent the shape, they are actually representative of the final parts, so we can manufacture them. So I think as it stands at the minute, there's the fascia plate of the whole centre console we were looking at earlier and thinking it would really be suitable for making a mould and doing it in either fiberglass or carbon. So now we're sort of going to the next step now and going and looking at the detail of it, what shapes it needs to be to get the draw angles when you're withdrawing the part from the mould, etc. So progress on that, and then George has moved on to the Quattro. So we saw that last week. We're just in the very, very early stages where we've got the model, 3D model of the shell. We've decided, I think, what size wheels, width-wise, diameter-wise, and offset we're using. We've kind of thrown them in the model on the hubs that we scanned on the car. So George can start kind of roughing out a body shape, and I've no doubt the many iterations have changed to that, but it's roughing it out at the minute so we can go, is that wheel size feasible, is it going to work visually? So you know, we'll watch this space on this one, very early days. Other than that, I think we're pretty much up to speed, so I shall see you next week.